Roger that. Confirm telemetry lock.
2, 1.
Could the world we've ignored for half a century be hiding a violent secret that rewrites everything we know? The seventh planet has always been dismissed as a frozen, boring, sideways rolling anomaly based on one fleeting flyby. We were dead wrong. Beneath its pale, featureless clouds lies a brutally scarred environment of boiling oceans, deep space diamond rain, and invisible magnetic storms. And now, it's finally waking up. Welcome back to the channel. I'm Raboscience, and today we're reconnecting with our old friend Uranus to uncover the terrifying and dynamic reality hiding beneath its hazy blue atmosphere. For nearly 4 decades, the absolute limit of our knowledge came from a single, fleeting encounter in January 1986. NASA's Voyager 2 probe zipped past, snapped a few photos of a seemingly dead sphere, and bolted for interstellar space. But thanks to the James Webb Space Telescope, along with brilliant forensic deep dives into decades-old Voyager telemetry, this forgotten orb is suddenly the most thrilling target in modern planetary science. We are finding secret oceans, bizarre space weather, and evidence of an ancient apocalypse. Let's start with just how alien this place really is. Uranus is a true behemoth. It sits nearly 2 billion miles from Earth, measuring 4 times wider than our home planet and packing 14.5 times more mass. But its posture is what makes it a total freak of orbital mechanics. Uranus is angled at a severe 97.8 degrees. Instead of spinning upright, it rolls around the sun like a massive bowling ball. Because an orbit takes 84 Earth years, this tilt triggers brutal, drawn-out seasons. Each pole faces the sun directly for 42 unbroken years of blazing daylight. Then, it plunges into 42 continuous years of pitch-black, freezing winter. When Voyager 2 finally measured the temperature of this sideways world, it broke our atmospheric models. At minus 371 degrees Fahrenheit, Uranus holds the absolute record for the coldest planetary atmosphere in the solar system. Yes, it is somehow even colder than Neptune, despite Neptune being a billion miles further away from the sun. Before we dive into the dark, crushing depths of this giant, to see what it's really made of, take a quick second to hit the like button and let me know in the comments. If you were in charge of naming the next billion-dollar NASA mission to Uranus, what would you call it? But that freezing outer shell is just a disguise. What lies beneath is a completely different story. The outermost layer is a toxic veil of molecular hydrogen and helium, laced with 2% methane. This methane acts like a massive planetary filter. It absorbs the red wavelengths of sunlight, reflecting back that iconic cyan blue hue. But if you took a deep breath of Uranian air, you would immediately regret it. Recent spectroscopic analysis confirmed the upper clouds are heavily saturated with hydrogen sulfide. The entire planet literally smells like rotting eggs. Beneath those noxious clouds, things get wild. Uranus is classically categorized as an ice giant, but any planetary physicist will tell you that is a massive misnomer. There is no solid ice down there. Instead, scientists believe Uranus hides a tiny, rocky core surrounded by a churning, super pressurized mantle of water, ammonia, and methane fluids. The temperatures inside this mantle aren't cold at all. They soar to an astonishing 9,000 degrees Fahrenheit. It is a boiling, electrically conductive ocean. Under crushing pressure, millions of times Earth's atmospheric pressure. The laws of chemistry warp. Methane molecules violently tear apart. Carbon atoms are squeezed together so tightly they crystallize. The result? It actually rains diamonds. Millions of microscopic diamond crystals sink through the fluid mantle, generating vast amounts of friction and heat as they fall. Researchers using high-powered X-ray lasers recently recreated these exact extreme pressures in the lab, proving definitively that deep space diamond rain is a real, ongoing phenomenon. But here is a massive plot twist. Is Uranus actually an ice giant at all? A groundbreaking 2025 study from the University of Zurich threw out the rulebook. Running thousands of randomized simulations against Voyager's gravity data, the math revealed something shocking. The rock-to-water ratio inside Uranus could be drastically higher than anyone previously calculated. Uranus might actually be a rock giant, hiding under a thin, liquid shell. If this rock-dominated model holds up, it completely rewrites how our outer solar system formed 4.5 billion years ago. Moving up from the diamond-filled depths, we reach the weather. For decades, the textbook consensus was that Uranus was meteorologically dead, a static, featureless blue cue ball. But fast forward to today, and next-generation observatories have violently lifted that veil. As the planet slowly approaches its northern summer solstice in 2030, the atmosphere is waking up. The James Webb Space Telescope recently captured stunning infrared images showing a glowing, bright polar cap of photochemical haze. Astronomers are now actively tracking colossal storm clouds erupting in the northern hemisphere. Some of these localized storms are vast enough to swallow the Earth entirely. The Hubble Space Telescope documented intense seasonal shifts over a 20-year period, proving that sunlight directly drives massive atmospheric upwelling. Thick aerosols are accumulating rapidly at the North Pole, drastically changing it from completely dark in 2002 to blindingly reflective today. Furthermore, a recent study confirmed the upper atmosphere is also heated by the solar wind. That means Uranus's climate is directly tethered to the explosive moods of our sun. In early 2026, JWST mapped Uranus's upper atmosphere in 3D for the first time, confirming a bizarre cooling and heating trend that actively defies earlier logic. Yet, despite these newfound megastorms, Uranus remains oddly sluggish compared to Jupiter or Saturn. Those massive gas giants have violent, swirling cloud belts driven by immense internal heat left over from their creation. This brings us to a major planetary mystery. What exactly happened to Uranus's internal heat? Uranus emits only 15% more energy than it receives from the Sun. For comparison, Neptune radiates more than twice the energy it takes in. Uranus is essentially a thermal zombie. To solve this mystery, we must look back to a cataclysmic event. High-resolution computer simulations from Durham University finally gave us the brutal playbook. Roughly 4 billion years ago, a rogue protoplanet, 2 to 3 times the mass of Earth, made of solid rock and dense ice, slammed into the young Uranus. It wasn't a head-on collision. It was a world-shattering glancing blow. In mere hours, this kinetic strike delivered enough energy to knock the entire massive planet completely onto its side. The shattered, melted remains of the alien impactor sank deep into Uranus, creating a hot, highly disordered shell wrapped tightly around the core. This layer acts like the ultimate thermal blanket. It actively traps the primordial heat inside the planet, preventing it from escaping to the surface. That ancient hit and run is exactly why Uranus is a freezing, low-energy world today. But this massive impact didn't just break the planet's thermostat. It also completely scrambled the magnetic field. On Earth, our magnetic shield is perfectly aligned with the center of the planet. not on Uranus. Its magnetic field is an absolute mess. It is tilted 59 degrees away from the rotational axis and completely off-center, shifted away from the core by a full third of the planet's radius. Because the planet spins on its side, this lopsided magnetic field tumbles wildly through space. It creates a massive, asymmetrical magnetosphere that corkscrews millions of miles into the dark vacuum. Every 17 hours, the magnetic field essentially opens and closes, tumbling like a tangled slinky, letting solar radiation pour in and out. When Voyager 2 flew through this magnetic field in 1986, it registered it as surprisingly weak and completely devoid of plasma. Scientists were baffled for nearly 40 years. They assumed the Uranian moons were dead rocks, unable to supply the system with charged particles. But in late 2024, a NASA-led team reanalyzed the raw telemetry and found the missing puzzle piece. Just days before Voyager arrived, a massive burst of solar plasma had slammed into Uranus. This freak space weather event compressed the magnetosphere into a tiny fraction of its normal size, squeezing the plasma out. Voyager simply saw a planet hunkering down against a rare solar hurricane, a condition that only occurs about 4% of the time. This revelation changes absolutely everything. The Uranian magnetic field is likely far larger and way more active than we ever imagined. And those supposedly dead moons, they might actually be incredibly alive. The shrapnel from that ancient collision eventually coalesced to form a bizarre, crowded system of moons. As of 2026, Uranus boasts an incredible 29 confirmed moons. The newest edition, officially designated S/2025U1, was spotted by the razor-sharp infrared optics of James Webb. This tiny satellite had been hiding in the bright glare of the icy rings for decades. And we certainly can't forget the rings. Uranus has 13 of them. Unlike Saturn's dazzling bands, the Uranian rings are practically invisible, made of the absolute darkest material in the solar system. We are finally going back to explore them. The scientific community has officially declared a Uranus orbiter and probe mission as NASA's highest planetary priority. To get a heavily armed scientific spacecraft to Uranus without it taking a lifetime, we need a massive gravity assist from Jupiter. The orbital mechanics align perfectly for an optimal launch window in 2031 and 2032. Uranus is no longer a joke. It is a deeply mysterious world, holding keys to how planets form across the galaxy. If you love this deep dive, smash that like button and subscribe to Raboscience right now. Turn on notifications so you never miss our next journey into the unknown. See you in the cosmos.